Hi everyone. In today's lesson, we're going to talk about how to graph angles in standard position. An angle is considered to be in standard position if its vertex is located at the origin and one ray is on the positive x-axis. The ray on the x-axis is called the initial side and the other ray is called the terminal side. So the vertex, I'll label it here, is where the angle meets, where the initial side meets and the terminal side meets. And when you graph an angle, you always have to remember that their positive angles are counterclockwise and its negative angles are clockwise, just like we did in geometry. So they're basically these three main components that we need for an angle. So the three main components are the initial side, the terminal side, and the directional arrow. So what do I mean by all that? We need an initial side, a terminal side, where the angle ends, right? To terminate means to end. So where the angle ends, and then this directional arrow here is necessary. And I'll explain why in a little bit. So let's just do a couple of examples together. So if I want to sketch an angle in standard position, we're going to start with an example of 135. The first thing you need to know is where the degree measurements are. So where your initial side is always 0 degrees. Then if you go 90 degrees, you're at 90, 180, 270, and then 360. These are all intervals of 90. So when you graph an angle, you need the initial side always. So the initial side is never going to change. It's always going to be on this right side of the x-axis. Now I want to graph 135 degrees. So you should see that 135 is in between 90 and 180. So we call this my terminal side. My terminal side is going to end there. And then we also need this directional arrow to represent that we went 135 degrees. So those are your three components: initial side, terminal side, and then the arrow to show the direction that you're moving in. And then the directions also say to state the quadrant. So we need to know a couple of things for quadrants. We can label that up here. We will say where I start the angle at the initial side is quadrant 1, continue to quadrant 2, quadrant 3, and then quadrant 4, right? That makes a full circle. We're starting at 0, then 90, then 180, then 270, and then 360. That's why the quadrants start here, 1, 2, 3, 4, to complete that full circle. Okay, let's try another example. So say I want you to graph 300 degrees. So again, we need an initial side. Initial side will always be here. That will never change. Maybe we should label our degrees. So we know that it starts at 0 at the initial side. Then we go up to 90, down to 180, 270, and then 360. So 300 degrees would be an angle that would be probably between 270 and 360. So we can go ahead and put our arrow in here. And then we also need our directional arrow to show that I'm starting at the initial side and moving around. So this gives me 300 degrees. All right, let's take a minute and do 65 degrees. So first let's label. We've got 0, 90, 180, 270, and then 360. So again, initial side never changes. The initial side is always here at the 0 marker. And I want to graph 65 degrees, which we know will be in between 0 and 90. So somewhere in the middle there is going to be my terminal side. And I start at the initial and I draw my arrow to show that I've gone 60. So I'm going to skip this example. You guys can try that one for homework, but let's try negative angles. So negative angles are the same thing as positive, except they just go in a clockwise manner instead of counter. So instead of going 0 degrees here and then up to 90, we're just going to reverse it. So we're going to start down here at negative 90, then negative 180, negative 270, and then negative 360. That makes one full circle. So if I want negative 120, I still need the three components of a line, or of an angle, excuse me. I'm going to start at the initial side, always never going to change. And now negative 120. So here's 0 to negative 90. Negative 90 to 180, it's probably somewhere down here. So we'll say here it was my terminal side. So now this is why the directional arrow is so important. I started here at my initial, and this time I went down and around. So that is negative 120. So that's why you need the components, right? You need the initial, the terminal, and the arrow, because otherwise there's no distinction between, do I want the positive angle or do I want the negative angle? So that angle and that arrow is very, very important. Okay. Let's talk about graphing one more. How about 485 or negative 485? So let's start by labeling. So we have 0, negative 90, negative 180, negative 270, and negative 360. Now, you must be thinking, negative 360 is not enough because I need negative 485. So that's okay. We can just keep subtracting 90. So if we subtracted 90 and went more, this would be same as 90 would be negative 450. So all I just did there was I took negative 360, subtracted another 90, I'm at negative 450. That's still not enough because I need to go to negative 485. So I'm going to subtract 90 again, and then that would give me negative 540. So that's what, oh no, this is in the way, sorry. That's what this angle up there would be. So we finally found it. So now we have our initial side, which is here, and we need to graph negative 485. So we're going to know that negative 450 is here and negative 540 is here. So it's probably going to be somewhere over here. So the arrow is super important. So we're starting at the initial side. We went one full circle, but then we went a little bit more. So I have to show that and go around more than once. And that would be your negative 485. All right, so what I'd actually like you guys to do for homework is try to do number 240 degrees. This should be a negative, so make this negative 400, and then negative 600, and we'll start by going over those three tomorrow in class. But I'd like to now move on to the next page. So angles that lie exactly on the x and y axis are what we call quadrantal angles. And you know what these are already. So 0, 90, 180, 270, and 360. Say I wanted you to graph 90 degrees. You absolutely could do that. Here is my initial side, always in the same spot. 90 degrees is up here. This so happens my arc or my directional arrow is like this. That's 90 degrees. I could ask you to graph 270 degrees. If I ask you to do that, we still label the same way. 0, 90, 180, 270, and 360. So initial side never changes. That's always going to be here. 270 is here. And I need my directional arrow, starting at the initial, going over. So this would be my 270. Now, I could also ask you to graph negative 180 potentially. So that's a possibility. That's a quadrantal angle as well. So we're going to go with 90 down here. So 0, negative 90, negative 180, negative 270, and negative 360. So again, we need our initial side, never going to change. And this time we're ending at negative 180, which is here. So that's interesting. That's a straight line. Well, that's okay. You learned that from geometry. 180 degrees makes a straight line, but the directional arrow shows us that we're doing a negative 180, not a positive 180. And then last but not least, I could ask you to graph negative 90 degrees. And if I ask you to do that, same thing is going to follow. We just graph it this backwards. So 0, negative 90, negative 180, negative 270, and negative 360. So we've got my initial side and my 90 here, negative 90. This time my angle is going this way. So as you can see, negative 90 is a quadrantal angle. That's exactly the same spot, right, as positive 270. We're going to talk about what these relationships are in another video, but it's just important to know that an angle could have, two different angles, but ending in the same spot. All right, that's it for today, guys. If you have any questions, now is a good time to jot them down. Otherwise, we'll see you guys in class tomorrow. Have a good night.